We're going to look at 3.12, day 3. So in day 3, we are going to be using primarily our sum and difference formulas to be able to evaluate some trig values. So let's go ahead and look at our first one, problem number 1. Just jump right into a problem. Now we are looking at a sine of 2 pi over 3 plus sine of 3 pi over 4. So we are going to utilize the trig identity where we have sine of u plus v, where I have two angles being added inside of the sine function. So looking at our identities, what is sine of u plus sine of v? Sine of u, cosine v, and then plus cosine u, sine v, like you guys said. Now, I want us to pay attention. So sine here, we are adding inside of the sine, and then we are adding as part of the formula. So that matches. And if you look at the sine of u minus v, the subtraction, we would also have a subtraction inside. Cosine, however, if you look at the cosine sum and difference, those signs change. When it's cosine of u plus v, you end up having subtraction in the formula. When it's cosine of u minus v, we end up having addition in the formula. So you want to pay attention to your signs and whether or not we're adding or subtraction both within the sign, the trig, as well as in the formula. So in this case, our u ends up being 2 pi over 3, and our v ends up being 3 pi over 4. So we are going to use this formula to expand this trig function. So using our sine sum formula, we start with sine of u. So that will be sine of which value? 2 pi over 3, good. And then next we have cosine of v, so that'd be cosine of what? And then we add cosine of u, and what's u again? Which I wrote that as 2 pi over 4 over there, so let me go ahead and fix that quick. 2 pi over 3, so that is 2 pi over 3. And then sine of, okay. Now, at this moment, 2 pi over 3 and 3 pi over 4 are angles on our unit circle. And we will be able to find the sine and cosine values at both of those angles. So at 2 pi over 3, what is the value of sine? That is our square root of 3 over 2. What is the value of cosine at 3 pi over 4? Negative rad 2 over 2. All right. And then what is cosine at 2 pi over 3? And sine at 3 pi over 4? Positive, right? All right, so all we're doing is we expanded with the formula. We substituted in the values from the unit circle to get where we are now. Now, one thing before we move on, I want to note, because I have seen it this year, I've seen it previous years, so don't write this next line, please. But what I have seen, instead of writing what we just had, I have seen people write this, that they're like, oh, 2 pi over 3 sine is rad 3 over 2. And they keep the sign there. And then they write the next one, okay, 3 pi over 4 cosine is negative rad 2 over 2. And that is wrong. Once we have picked our values from the unit circle, we do not need to write sine and cosine anymore, because rad 3 over 2 is the value of sine. I don't need to write sine again. If you write sine again, sine of rad 3 over 2, it's as if you're saying, okay, I'm going to plug rad 3 over 2 into the function of sine. And that would be incorrect. It'd be the same thing as if I said, hey, here's a function, and let's say the function at 2 is equal to 3. And then I said, okay, what is 5 times f of 2? What is that equal to? Well, what is that equal to? Why 15? Because this gets substituted for all of this, and we just have 5 times 3. But if you're plugging in the value back into the function, you would be saying that this is instead 5 times f of 3. And that would be wrong. This is not equal to that. They are not the same thing, unless by some chance f of 3 is equal to 3 as well. Right? So we don't take the value and plug it back into our function. It's the same thing over here. I don't take my value and plug it back into my function. I'm making a big point of that because I have seen it and I don't want to see it anymore. So please be careful with that. All right, from here we are just going to multiply those up and simplify as much as we can. Now this is, we're wanting the exact value, so we're not given a decimal answer. So let's just go ahead and multiply that. Rad 3 times rad 2, what is that going to give us? Square root of 6. 2 times 2 is 4. And then that will be plus negative rad 2 over 4. Do we have common denominators? Fantastic. So we can go ahead and just combine this into one fraction, the denominator of 4. And that would be negative rad 6 minus rad 2. And that is as far as we can simplify that. We cannot simplify it any further. Please do not write that as like negative rad 8 or negative rad 4 or something like that over 4. And please do not try to simplify the 6, 2, and 4. Do not write that as rad 3 minus rad 1 over 2. That would be incorrect. The 6 and the 2 are inside of radicals. You cannot touch them with anything except for some other thing that is inside of radical when you're multiplying. To be able to add radicals, the radicals have to be identical, but these are not. So, and that is that problem. We are done. So again, we have the sine value, or we had two angles being added, so using our sum and difference formula, we expanded it out, used values from our unit circle, and then simplified. So we're going to do a very similar thing on problem number 2. So I want us to go ahead and look at problem number 2. Does anybody have any questions on problem number 1 before I move it up? All right, moving it up then. Problem number 2, we are asked to find the value of exact value of cosine of 5 pi over 12. But what do they tell us 5 pi over 12 is equal to? So we can substitute that in and say, okay, well then that's equivalent to cosine of 2 pi over 3 minus pi over 4. And now we have a sum and difference situation. We have a cosine. This would be a cosine of u minus v situation here. So I want you to go ahead and look at that. Like what we did for the first problem, I want you to expand that out and then see if you can use your unit circle to simplify down. All right, so go ahead and try that out, please. Okay, one thing that came up I want to point out here, when we do cosine or any subtraction like this one, we have the u minus v. In the formula, that is u minus v, and when we write it out, that is cosine of u times cosine of v, not negative v. Okay, so when we write it out, that is going to be cosine of 2 pi over 3 times cosine of not negative pi over 4, but just pi over 4. Now, I could do it as negative pi over 4, but if I do, this is what you would have to do. You would have to write this as plus a negative. And so then it is no longer a cosine of u minus v, but is instead a cosine of u plus v, with the v being negative. So you could, if you wanted to, it would come out as the same. But since we already have a difference formula, let's go ahead and just use it as a difference formula. All right? So pi over 4 should be positive as you're putting it through. All right? And then this one, with this subtraction, it's going to be addition. And what would be the rest of that problem? So let's go ahead and finish this out. Ben, can you finish out the general formula up here where I have it highlighted? What would I have there? Sine of u times sine of v. And so down in our problem, Ben, what would we have? 2 pi over 3 times 4, good. All right, let's go ahead and find those values. Cosine at 2 pi over 3. Chris, what is cosine at 2 pi over 3? Cosine at pi over 4? Let's see. Orlando, what is sine at 2 pi over 3? Rad 3 over 2. Square root of 3. Sine at pi over 4? All right. Go ahead and multiply those. Gabriel, what would I get when I multiply these first two?
Negative rad 2.
And the second two?
Negative rad 6.
Do I have? No negative though, right? Should be positive. All right. Oh, and over 4. I wrote over 2. 4. All right, and so combined up, we should have negative rad 2 plus rad 6 over 4. All right, any questions on that? All right, if there's no questions, are we all good with problem 2? Can I move it up? Yes? All right, so let's go ahead and look at B here. We want to find the exact value of tangent of pi over 12. What's the difference between this problem and the last one? They don't give us that like sum or difference, right? Yeah. So we're just pi over 12. The last one, we were cosine of 5 pi over 12, but then they told us, hey, 5 pi over 12 is this. And sometimes they will tell us what the adding or subtracting is. Sometimes they may not, and we have to figure it out. Thankfully, it doesn't take too long to figure out a correct adding or subtracting that will work for us. So we want to take pi over 12, and we want to find two angles that I can either add or subtract together to get 1 pi over 12. Now, if we think about this, if I am wanting to get 1 pi over 12, am I going to want to add or subtract two numbers to get 1? Let's think about this a little bit more. Okay? So both of these are going to be fraction. And let's go ahead and put both of them with a denominator of 12. Because to add or subtract, we need common denominators. So we're just going to go ahead and do that. And I'm going to go ahead and put pi on the top for each of these. And we want two numbers that I could either add or subtract to get 1. So again, would I want to add two numbers to get 1 or subtract two numbers to get 1? Makes more sense to subtract, right? Okay, so let's think. What are two numbers that subtract to 1? 2 pi minus 1 pi. Okay, so that would work. So let's go ahead and try that. So 2 pi over 12 minus 1 pi over 12. Would that work? All right. Now the next thing that we have to check, if we look again at this last problem, the two that we had were two angles on the unit circle. So what we have to check is, do the two angles we picked reduce to angles on the unit circle? So 2 pi over 12, does 2 pi over 12 reduce? What does it reduce to? Is that on the unit circle? All right, so we're good with that. However, does 1 pi over 12 reduce? And that is, again, not on the unit circle. And so, does this pairing work? So let's try a different pairing. So let's try it again. Any thoughts? What could we do? Okay, so if we start with 4, all right, so 4 pi minus 12, what would we have to minus it by to get 1? 3. All right, let's try those. Does 4 over 12 reduce? What does it reduce to? Pi over 3. Is that on the unit circle? Okay. What about 3 pi over 12? Does that reduce? To what? Is that on the unit circle? All right, so then we're good. Are there any other combinations that could possibly work? Yes, there are. Let me show you a couple more. Let's say we did pi over 12 was equal to 10 pi over 12. If I do 10 pi over 12, what would I have to subtract it by? Okay, can those reduce? What is the first one? And the second one? Are those on the unit circle? Okay. So does it matter which one we use, the pi over 3, pi over 4, or the other two? No, they're both going to be equivalent in the end. We're going to go ahead and use this first pairing we found. All right, so both are fine, both work. You can choose, but I'm going to go ahead and use the first one. Now, which trig function are we looking at? Sine, cosine, tangent, which one? All right, do we have a formula for tangent? So tangent of pi over 12 would be equal to tangent. We're using pi over 3 minus pi over 4. Is there a tangent? Is there a formula that's tangent of u minus v? Do we have it listed? No, we do not. Technically there is, but I didn't list it for you. Because going back up to the quotient identity, what is tangent equal to? So instead of using a tangent formula, I can instead think of this as a sine divided by cosine formula using our quotient identity. So we're using kind of two identities combined into one. And so this is why I didn't give you the tangent, because we can just use the quotient to find the tangent. So we're going to do the sine formula in the numerator and the cosine formula in the denominator. So in a sense, I have sine of u minus v divided by cosine of u minus v. So look at your sine of u minus v. Use that to get your numerator. And then look at your cosine of u minus v formula and use that to get your denominator. So I want you to go ahead and see if you can fill out what would be our numerator, what would be our denominator. And then if you want to venture forth and use your unit circle after that, go ahead. I'm going to go ahead and check in with that in about a minute. Okay, ladies and gentlemen, one thing I do want to mention is that please do not fall in the trap of saying that this, or even this one up here, is just sine of u minus sine of v. You cannot distribute the sine. That is incorrectly done. We do not distribute the sine. That is incorrect. You have to use the entire formula. So what is the whole formula for sine of u minus v? Well, we would start with sine of u, which is pi over 3, times what? Cosine of what? All right. And do I add or subtract on this one? Subtract, because it's sine. Minus, what's next? Pi over 3 times sine of pi over 4. So you have to use the full formula. You cannot just distribute. That is incorrect. All right, that is sine. Now let's look at the denominator. What is cosine of u minus v? Let's see, starting it out would be cosine of u. So that would be cosine of pi over 3 times what? Cosine of pi over 4. And then are we adding or subtracting on the cosine? Adding. Cosine, it's the opposite. If we see subtraction, we actually end up adding. And then what am I adding? It's the sine. Sine of pi over 3 times sine of pi over 4. That is the whole expression, the whole thing expanded. Now use your unit circle and see if you can simplify. All right, let's go ahead and get our values and combine things up. Let's pull them from our unit circle. Starting with the first one, sine of pi over 3. Mandy, what is sine of pi over 3? Rad 3 over 2. Okay. So we would have rad 3 over 2. And Mandy, what is cosine of pi over 4? Pi over 4. Okay, minus, and now on to the cosines there. Aaron, what is cosine of pi over 3? 1/2. And sine of pi over 4? All right, and then going to the denominator, the cosines for those two, kind of already pulled those. So cosine of pi over 3 was 1/2. Cosine of pi over 4, rad 2 over 2. And that is a plus. Sine of pi over 3 is rad 3 over 2. And sine of pi over 4, rad 2 over 2. Let's go ahead and multiply. All right. When we multiply, we're going to get a common denominator and we're going to combine them. Can I go ahead and do that in one step, guys? Are you guys okay with that? Meaning, can I go straight to rad 6 minus rad 2 over 4? Can we make that jump, guys? Okay. And in the denominator, rad 2 plus rad 6 divided by 4. Are we good with that jump, guys? Okay. Now, we have a fraction divided by a fraction. How do we divide fractions? So let's do that. So rad 6 minus rad 2 over 4 times 4 over rad 2 plus rad 6. All right. What can cancel? And be careful. The 4s. Can anything else cancel? Thank you for saying no, because it is a no. Only the 4s can cancel. And so I end up with rad 6 minus rad 2 over rad 2 plus rad 6. That will be our answer. Technically, we could rationalize this, and maybe at some point you might need to, but for right now, that is fine. So if you watched the end of the lesson video from yesterday, this type of problem should look similar. It is a verifying type problem using our identities. They've given us one function f and another function g, and they're wanting us to show f is equal to g. So like we normally do, we normally start with the left-hand side, and that's what I'm going to go ahead and do here. So I'm going to start with my left-hand side f of x, and that equals, well, what is f of x? What did they tell us? X minus pi over 4. Do we have a difference problem like we've been looking at? Sum or difference here? Similar, not exactly the same, but would this be a sine of u minus v? Yeah. So can I utilize the sine of u minus v formula? Yes, we can. All right, how does that go? Sine of u minus v for this particular problem. What would I start with? Sine of, well, that would be sine of u, right? And what is our u? X. And then sine of u times cosine of v, which in this case, yes, is pi over 4. And then for this one, would I add or subtract? So minus, what would I subtract? Cosine of u, or in this case, cosine of x, times sine of v, or pi over 4. All right. Is there anything that we can pull from the unit circle, any of those values? The pi over 4s, right? Do we know what x is? No, we don't know what x is. But we do know pi over 4. And what is the value of cosine of pi over 4? So that is times rad 2 over 2. What is the value of sine? The same thing. All right. Now, I want you to look at our end goal. Our end goal is g. What is the difference between what we have written and what they say g is equal to? What did they do with the rad 2 over 2? They put it in the front, right? Can we do that with our problem? If two things have something in common, can't we factor that thing out? They both have rad 2 over 2. So if I factor out rad 2 over 2, what are we left with? And isn't that what our end goal was? That was g. And remember, our goal was to show that f was equal to g, and now we can follow things through. We started with f, we ended with g. We have all this equal in between. There we are. So now we can conclude that, therefore, yes, f is equal to g. These three little dots mean like a therefore, thus, or we conclude that, or whatever. But we're good. Which again makes us happy.